Hey guys, it's Mr. Bostrom, and today we're going to talk about counterexamples. Okay? We actually have already been doing counterexamples in some of our previous assignments. I just haven't told you that this is the word and what it means. Okay? So a counterexample is an example that proves a statement is false. So if you think back to our assignments where we have to say, like, is the conditional statement true or false, and the converse and the inverse and all of those, right? And you check if it's true or false, you're actually searching for if you can find a counterexample. So when we were going through and we were like circling all the scenarios and checking does it work every single time, that was us trying to find counterexamples, and when we did, we said it was false. So you kind of already have found counterexamples, and now we're just learning like what does the word mean and applying it more to more realistic math problems rather than random statements about like calories and materials and shapes and all of that. We're going to apply it to actual, math topics that you might do in a geometry class. Okay? Before we hop into that though, and actually try to find some counterexamples, there's some vocab that we need to talk about that will make the assignment easier because they're going to use these words. So if you don't know these, well then it's going to be hard to prove a counterexample, right? Because you don't know what we're talking about. So at the very top, we have complementary angles and we have supplementary angles. A lot of the time, students kind of remember what these mean, but they get them mixed up. Okay, so here's how I'm going to help you with not mixing these up. If you notice, complementary angle starts with a C and supplementary angle starts with an S. So whenever you're trying to think, okay, which one do I use, ask yourself this. Which one comes first in the alphabet, C or S? Well, C comes first in the alphabet. And if you look at its equation, it says it only adds up to 90, right? It only adds up to 90. And 90 comes before the 180 degrees that you get from supplementary. So complementary angles, C comes first in the alphabet, so it adds up to 90 because it comes first before 180. Supplementary angles starts with an S, it comes later in the alphabet, so it adds to 180 because it comes after 90. Okay, that's my main method that you can use right now. Like, which one means what again? Is complementary 90 or 180? Well, C comes first, 90 comes first, so complementary goes to 90 degrees, okay? And if you're not sure what the equation is saying, all that's saying is that if I take two angles, and it looks like I forgot to write the angle part right there, there we go. If I take two angles, a complementary set of angles will add up to 90 degrees. So if they say, hey, I give you two complementary angles, all they're telling you is that if you put them together, it equals 90. Same thing for supplementary angles. They say, hey, if I give you two angles, they add up to 180 this time. Okay, that's all that's saying. And hopefully I'll get an example of that when I start doing some Alex problems with you guys. All right, and then usually students remember these, but just in case if you need a reminder, they also use the words acute angle, right angle, and obtuse angle. Most of you know right angle, right? If not all of us, is equal to 90 degrees. Acute angle is less than 90 degrees, and an obtuse angle is greater than 90 degrees. I'm pretty sure all of us kind of know this, but if you need a reminder, there you go. All right, so with that vocab, I'm going to just do a couple Alex examples until I think I've kind of covered most of the things that you'll see, and then you can try it on your own. Okay, so let's go to that. Again, I would write those definitions down if you don't have them like 100% memorized, like on your desk or in your journal, so you have them for later, and try to get used to memorizing them because they will show up on tests in the future. Okay, so this is what your Alex assignment will look like. It's going to give you a bunch of if-then statements. Okay, so if I look at the first one, it says if the length of xz is 20 and point y lies on xz, then xy equals 12 and yz equals 8. Now, you might read that and be like, what the heck did I just read? Well, I'm going to draw it out for you, okay? That's why I'm doing a few examples with you. So let's get to where I can write. And I'll draw this scenario, okay? Whenever they use two letters with a bar on top, if you haven't noticed in previous assignments already, this just means that it's a line segment. So basically, they're saying that if I have a line, let's see, if I have a line that starts at X and goes all the way to Z, it's going to be 20 units long. Okay? And then they said, well, hold on, there's also a point Y that's on this line, so I'll just put it anywhere for now. and I'll call that y. They're saying that xy has to be 12, so from here to here needs to be 12. And then y to z needs to be 8. All right? And they're telling us make a counterexample of that. So how do we make a counterexample? Well, we're going to kind of use the same idea that we used in our previous assignments, where we're going to say, okay, I'm going to take your if statement, right, the condition. So in this case, our if would be if the length of xz is 20, and there's a point y that lies on the line, okay? That's our if statement. If I take their if statement and I follow that rule, can I break the second half? Basically, I want to say, if I follow the beginning, can I rewrite the ending? Okay? Because then I'm following their only rule, which is if all of that in blue, right? That's the one rule I have to follow. They're saying that the red part should just naturally happen, right? That's their statement. Well, my job right now is to disprove their statement. So I'm going to say, well, I'm going to follow the first half and break the second half, okay? That's our strategy. So if I go back, before I wrote all of this, all the blue says is that if the length of xz is 20 and the point lies on xz. So that's what I have, right? I have a line segment from x to z that's 20 long, and I put a point y on there. Now, could I make different numbers other than 12 and 8 for the lengths that they gave me? Sure. Let's try, I don't know, maybe just 10 and 10. Right? It looks like I put my y value kind of in the middle. They didn't say where the y value had to be. They just said it's on the line. So if I put my y value towards the middle, I could say, hey, I can have xy is 10 and yz is 10. And that would be an example that disproves their statement because the ending does not match my ending. Okay? So all we would do there is we would write 10 and 10. Now, is 10 and 10 the only answer? No. I could have said, let's see. I have to add up to 20. I could have said 2 and 18. Right? I could have said 3 and 17. Even if it's not drawn to scale, I know that I could use those numbers, right? I could just move the point around to make a better picture. But as long as I follow the fact that the beginning distance is 20, and I put another point on the line, can I make up two new numbers for those from x to y and then y to z? Absolutely. Okay, so that would be a counterexample, right? There's lots of possibilities. So their statement is not true all the time because there's other answers available. So that would not be a true statement. Okay. So that's an example there. Let's try the next one. The next one, part B, says, if angle 1 and angle 2 are complementary angles, see, there's where those vocab words come in, then one of them must have a measure greater than 45 degrees. Okay, so measure 1 and measure 2 are complementary. If we go back to our notes, it says that they have to add to 90. So I'm going to just make a little note right here. Because again, we're only going to follow this part at the beginning. Right? I'm going to follow the first half and try to break the second half. Okay, so let me erase that just so we can see it. But we want to break that second half. We want something that doesn't give us an angle greater than 45. But I have to follow this rule. Angle 1 plus angle 2 equals 90 degrees because they were complementary angles. So can I put two angles together that equal 90 degrees, but neither one of them are greater than 45, right? Because we're trying to break this. I don't want any of them to be greater than 45 because I'm trying to disprove this statement. I think it's false. Well, what if I make both of them 45 degrees? I could say I have a 45 degree angle. That's not greater than 45. And I could say I have another 45 degree angle. That's still not greater than 40. Or sorry, it's still not greater than 45. Yeah. But if I add them together, I still get my 90 degrees. So would this disprove their statement? Yes, because did we ever get greater than 45 degrees? No. So we did not follow their statement, but still followed the beginning half, right? Or the first half of the statement. So that would disprove their statement. Because I followed the beginning, I followed your rule that you gave me, but I got a different result than what you said was going to happen. So I could say, well, what would be a counterexample? Two 45 degree angles. And there we go. Moving on. We are on to part C. Part C says, if the measures of angle P, angle Q, and angle R sum to 180 degrees, then all the angles must be acute. Okay, so they gave me 3 angles, and they add to 180. Does that mean that all of the angles have to be acute angles? Well, let's find out. Again, we want to only follow the first half. So the only rule that we have to follow is these 3 angles have to add to 180. So we have to follow angle 1 plus angle 2 plus angle 3. Or you could have wrote angle P, angle Q, angle R, like they did. But I'll just leave it like this. Equals 180. And we're trying to keep in mind that I don't want all of them to be acute. Right? They use the word all. So if I can make just one of them not be acute, that would be good enough to disprove their statement. Right? Because they're trying to say that all 3 of them have to be acute angles, which all 3 of them have to be less than 90. So what if I just make one of them equal to 90? Right? What if I said, well, angle 1, what if I just called that one 90 degrees? And if I can make this work, well, then I've already disproved it, right? Because that would be a right angle, not an acute angle. All right, what else can I put on there? Let's do maybe 30 degrees. So 30 degrees, 90 degrees. 90 plus 30 would give me 120. So I would still need 60 degrees, I believe. Let's see, 60 plus 30, 90. Yep, that will work. And now I have 3 angles that equal 180. But are all of them acute? No, because I have a right angle. So did I just provide a counterexample to that question? Absolutely, right? So I could say one of them is 90, one of them is 30, one of them is 60. Again, is that the only example I could have used? No, I could have maybe said like 110 as one of the angles, and then maybe like 20, and that would give me like 50 left over, right? There's a lot of different counterexamples that you can use from, or that you could use on this assignment. Okay, so again, basic idea. I follow their first half, right? I had to follow the rule they gave me in the beginning of the statement, but then I try to break the second half of the statement and try to make something different out of the second half. Okay, let's try our last one here. Let me just erase all this, get this out of the way. So the last one says, if the perimeter of a rectangle is 48, then the length must be 12 and the width must be 12. All right, so again, I had to only follow the first half if the perimeter of a rectangle is 48. So let's draw a rectangle. And let's see, can we make a rectangle where the perimeter is 48, but we use different lengths than 12 and 12, right? A different length and width than 12 and 12. All right. Here would be my suggestion for this type of problem is just pick a number to try to use rather than trying to solve the whole problem in your head, because sometimes you get lost in your head and you like sit there and you think too long, okay? So I would just say, all right, I need to add up to 48. Let's try to use like the number 10. Okay, so I'm going to make my, let's make like the width 10 on both sides. And let's see if I can make that work, okay? So if my width is 10, then so far I have 20 if I add that together, right? 10 plus 10 is 20. So I still need to get 28 more because I need to add to 48, right? So what's a number that would add to 28? That'd be 14. Okay, so let's check. 10 plus 10 gives me 20. 14 plus 14 would give me 28. And I believe that gives me the 48. So there we go. Did I just come up with a rectangle that has a perimeter of 48 like they wanted, but use different side lengths than the one they said should happen? Yes. So this is another counterexample because I followed their beginning rule but didn't get what they said should happen, right? I got a different scenario. So their statement is not 100% true. It might work sometimes, but not all the time, right? And we only want statements that we can use 100% of the time. So we could say the length is 14 and the width was 10. All right, and there we go. If I go back, let's see if I can remember everything we did. I think for this one, what did we say? 10 and 10? This one we said they were both 45. And again, a lot of these have multiple answers. They're not like only one answer that works. You can come up with different numbers in a lot of these, okay? I think we said that one of our answers was 90, 30, and 60. And then we had like 14 and 10, I believe, at the end. So we're all those counterexamples. There we go. Okay, so that's the basic idea. Now, I think there's one that usually gets students, kind of catches them off guard. So let me see if I can find it. Area of a rectangle, very similar to what we just did. They use supplementary angles on this one. They use another line segment. And they do another where you have to add them to 180 and, you know, have to do that. All those are very similar. So I'm not going to do those. Unless you guys have trouble, send me a Canvas message. I'll make some more examples tomorrow. But I think we're good on those. There's a specific one I'm trying to find about an interior angle. There we go. Part B. Okay, let's look at part B. Oops. That's not what I wanted. I want to be able to write. Okay. If you look at part B, this has a lot of like new ideas that we will get used to by the end of the year. But right now we haven't really talked about these sort of details. Okay, so I'm going to go over it right now. It says if the measure of angle WXZ, basically they're saying, hey, how big is the angle? It's 42 degrees. Okay, that's all that said. The little m is just going to say, hey, how big's the angle? Because it stands for measure. All right? So the measure or the size of angle WXZ is 42 degrees. And point Y is in the interior or the inside of this angle WXZ. Again, I'll draw this out in a second so that we can go over that. Then the measure of WXY is 28 degrees and the measure or the size of angle YXZ is 14. Okay, lots of stuff happening. Lots of letters, lots of words. Stay with me. The reason that they're using so many letters for the angles is because of this. If you think about an angle, okay, an angle has 3 points that make it up. So if I draw an angle, and let's say I'm drawing this first angle they talk about, WXZ. Well, I have W, then X, then Z would make that angle. Okay? And then it's saying that the measure of this angle is 42 degrees. So I could say, hey, this angle is 40. Let's try that again. 42 degrees. That's what that first part says. Okay? So all the beginning says is, hey, you have some angle that uses the points W, X, and Z in that order, and it's 42 degrees big. Okay? Keep in mind that I said in that order. If I read this angle as it appears in the problem, it says WXZ. Oh. That means that I cannot write this angle and say WZX. Right? That's not the same order they wrote it in, so that's not going to be the same order that we write it in. Okay? May not cause issues for this problem, but in the future it does cause issues. So we're just going to get used to that. Okay? So WXZ, simple enough. And then it says there's a point Y in the interior. Well, interior means inside. So we're going to be inside the angle and put a point Y. So maybe Y is right here. That's all that means. So somewhere in between your angle, you're going to put a point Y. All right, that is the first half of the statement. So this is the setup of the problem. And they're saying if this happens, then the only solution should be, let's take that now. The only solution should say that the measure of WXY is 28. So again, I'm going to follow those letters. W to X to Y makes that angle. And they're saying that this should be 28 degrees. And the measure from YXZ would be that angle. Or you know what, let me draw it from Y. So Y to X to Z, which is 14 degrees. And they said that's the only possibility. Okay? if you set up that WXZ with the Y in the middle, that's the only possibility for the two new angles that we can make. Okay? So let's try it ourselves and say, well, let me just try to draw my own example then and see if I agree that I get the same thing. So again, I have to only follow the beginning. So I'm just going to draw WXZ and make it 42 degrees big and put the point Y inside of it. Okay? That's what their if statement says. So I'm going to have some angle. It's going to be WX, then Z. I'm going to remind myself that it's 42 degrees. And then I'm going to put the Y somewhere in between all of that and put it over there. All right, second half of the statement. They said it has to be 28 and it has to be 14. And I go, no. How about I just use 40 and 2, right? What if I said the measure of WXY, so from W to X to Y, what if I said I made that only 2 degrees? Well, then the rest of it would need to be 40, right? Because the original angle that we're cutting up was 42 degrees. So if I take YXZ, that needs to add to 40 degrees because it still needs to add up to our original angle, right? Because we're not making completely new angles. We're just kind of cutting this angle into two parts. All right? Hopefully that made sense. I tried to take it slow and take it down piece by piece. But that is like the only thing that I think catches students off guard after vocab. Okay, that's like the hardest one. And it's just because you have to think about the word interior. You have to think about angles when you write them with 3 letters, which we haven't gotten used to yet. You have to make sure you put them in the right order. And there's just a lot to get confused by. Okay, so if you're having trouble on that, try to rewatch this part and how we just set up the very first one, this one over here, because that kind of explains how the statement is being written. And as long as you can understand like the start of the problem and like the original image, I think you can go from there and making a counterexample. Okay? So just make sure you understand what they're saying and that you can recreate it on your desk or when you draw it. Alright? But other than that, a lot of the other examples in this are just, those vocab words I talked about, or very similar to like the first 4 examples I gave you. Just maybe instead of perimeter they use area and they use different numbers, things like that. But I think other than that, you guys should be good. If this isn't enough examples, again, send me a Canvas message. Maybe tell me which one specifically is like throwing you off, if there's one in the class that like everyone's having trouble on, and then I'll come back and make another follow-up video on it for tomorrow. Okay? But other than that, good luck on the assignment and have a great day.